Hello, this is Math Jazz from Almost Cool, and today I wanted to try something different for our math live stream. I am going to write a program that does linear programming in the simplex tableau method. And if you have any questions, then please ask them in chat, and I will start programming now. Okay. So, I want to create a function that will take in a matrix and will do all of the pivoting operations that will cause it to solve my simplex methods. So let's create a module. I'm going to create a function called pivot. No. I'll create a I'm going to create a function called pivot, and it's going to take in our matrix, which we'll call matrix A, and it'll take in, let's say that it takes in, let's call it matrix, and it'll take in a pivot. So the pivot that it'll take in will be in coordinate form. So, like, for example, if the pivot is the second row and the third column, then it'll do row operations on that part to it'll take the matrix that I give it and it'll pivot around the particular spot that I tell it to. Okay. So we'll create a module. Whoa, that was weird. There we go. So the way that we work with modules in kill the evaluation here. The way that we work with modules in Mathematica is we basically everything that's inside of this code between the brace, this square brace here and this square brace here, is our module. And any variables that we declare inside these curly braces here are local to this module. It means that they can't be accessed from outside the module. It's a great way to break up your programming so that you can have local variables that don't get interfered with from other sources. So let's see. So the way that the way that we pivot, so let's see. When we do our operations with our pivot, we have to look at all of the entries that are in the same column, and we want to make those equal 0. So I guess we have to go through row at a time. So we'll have a current row as one of our variables, and we'll set that equal to 0, and we'll need to have our pivot entry, and we'll set that equal to, the way that we select entries out of a matrix is like this in okay, so what I'm doing here is I'm taking the matrix that I'm handing this method, and these double square braces after a variable mean that the variable is actually a list of values, and I want you to pick out the value that is inside the square braces. So for example, if I had a matrix A and I go like this, or if I have a list A and I go open square brace, 3, close square brace, that means pull the third element out of the list A. If I go like this, that means I have a matrix, and it means pull the third row, second element in the row, out of the matrix. So what I'm doing here is my pivot is a list. It's a first number and a second number. The first number is the row, the second number is the column. So I'm taking the matrix and I'm pulling out the pivot 1 row. So this is the first element in our list of 2 numbers pivot. And then I'm saying inside of that row of the matrix, pull out pull out pivot 2 from that row. So pivot 1 is the row, pivot 2 is the column, and I'm saying go to matrix and pull out row pivot 1, column pivot 2. So that's going to give me my pivot entry here. Okay, and I'm also going to need a current row entry. Okay, which I'm going to set equal to 0. Great. So I want to do a for loop now. Oh, I also probably want to have a number of rows. That's going to be equal to length of my matrix. Okay, so what I'm doing here is when you call the length function and stick a variable in, what it does is it counts how many elements are in the first level of that variable. So this matrix is a list of lists. So we have the matrix, which has a list inside of it, and in each spot of that list is a row of our matrix. And then that row is also a list, and the elements of that list are the entries in that row. So we have a list of lists. That is, the little lists are rows with entries in them, and the big list is the whole matrix with rows in it. And so by calling length of matrix, I'm counting the number of row lists in the matrix and storing it in number of rows. Okay, so what I want to do then is, I guess current row, we'll start current row at 1, not at 0. So we'll have a for loop. For loops work by, we create an, let's put an index and set it equal to 1. In some languages, you set your index equal to 0 to start with. But we're going to set it equal to 1 because that's how Mathematica prefers it. So what we do is index. The first thing that we do is we check. The first thing in a for loop is it checks to see if a certain condition is true or false. So we're going to check that the index is less than or equal to the number of rows. And when we start, it'll be 1, which should be less than the number of rows because we don't have matrices with 0 rows in them. Okay, so it checks to see, are there is the index still less than the number of rows? If that's true, then we will do all of the code inside of our for loop. If it's false, then we're going to drop out of the for loop, move on to the next line of code. So if the index is less than the number of rows, then actually we have to start index equal to 1, then see that the index is less than the number of rows, and then we do index ++, and then we do our body of our for loop. So what this means is that we're going to set index to 1, which we did, but we're going to, that's also just how we're going to do it again. I've made index a local variable inside the module so it doesn't get messed with by anything else, but in the case that it does get messed with somewhere else, at least our for loop will set it back to 1. Okay, then it'll check to see if the index is less than the number of rows. If it is, then it'll do this body of code that we're going to type. And then after that's done, it's going to add 1 to the index and then check again, is the index still less than or equal to the number of rows? So the body of text now is that we want to do row operations. So the first thing we want to do is we want to figure out what combination of the pivot row and the current row will make the entry in the pivot column and the current row equal to 0. Okay, so we want to look at the matrix. We want to pull out the current row, comma, the pivot, the let's see, current row, and then we'll take pivot 2. So pivot 2 tells us, pivot 1 tells us which row the pivot is in. Pivot 2 tells us which column the pivot is in. So when we look at the current row of the matrix, comma, pivot 2, that'll tell us to look at the current row that we're trying to reduce, and then look at the element of that row that is in the pivot column. Okay, so this is the correct number that we're looking for. But we want to figure out what combination of this number with the pivot will make 0. So what we're going to do is, now we don't have to worry about fractions because the computer is going to handle that all for us. So I guess we're going to take okay, so our pivot is going to be matrix pivot 1, pivot 2. Okay, so what I want to do before I do anything is I want to divide my pivot row. Yes, this is what I want to do. I'm going to take the pivot row of the matrix and I am going to divide it by the pivot so that I get a 1 in the pivot column. And that'll make everything easier in the long run. So I'm going to take okay, so what I have written here is yes, I have to delete this too. Okay, so what I have here is I'm going to say take the pivot row and store it in the pivot column. Remember, equals in a single equal sign in most programming languages means take the thing that's second and store it in the place that's first. So take the right-hand side, do whatever computation is there, and then store it in the place that's mentioned on the left-hand side of the equal sign. So right now I have take the pivot row and store it in the pivot row. But what I want to do is I want to divide this pivot row, divide every entry in it by the pivot. So what I have here is this is the pivot row, and I'm dividing every entry in it by, this is the pivot entry itself. So this will divide everything in the pivot row by the pivot entry and store it in the pivot row. Okay, and then now that I go back to my for loop, now I know that my pivot row has a 1 in the pivot. So what I'm going to do now is I'm going to take this, I'm going to take the current row, which is this row here, and I want to do a row operation to it that will remove, it'll add or subtract copies of the pivot until we get a 0 in the pivot column current row entry. I guess current row pivot column, you do rows first and then columns second. So we set this equal to the current row minus this is the entry that's in the pivot column and the current row. So, but we want to multiply this element by the pivot column. Sorry, the pivot row. Okay, so what we have here now is take the current row and subtract from it the pivot row times the entry in the current row and pivot column. So, like, for example, if I had a matrix that was like get a matrix here. Oops. I have to take it out of my programming loop here. So I have this matrix here, and let's say that this was my pivot row. This is my pivot entry. What this line of code does is it takes this row, and then it subtracts, oh, I guess I can't choose this as my pivot. The earlier line of code changes my pivot to a 1. So the first line of code goes through and says, well, if this is my pivot, then I'm going to divide everything in the pivot row by 4. There you go. There we go. Okay, so I have this matrix, because my first row turns the pivot into a 1. So I have this matrix here, and this is the pivot row, this is my pivot, and this 2, 1 here is my pivot column. So what this second line of code does is it takes the row that I'm looking at, which is not going to be the pivot row. It's going to be all the other rows because I'm trying to kill off all the entries that are in the pivot column but not the pivot. And then it's going to take this entry, which is in the current row and in the pivot column. That's this entry here. It's going to multiply this by the pivot row, and then it's going to subtract what it gets from the current row. So I would get 2 times this row, 3/4 1 is going to be 2, or 3/2 2. And then I'm going to take this row and subtract that from it. So I get 1 minus 3/2 is going to be a -1/2, and 2 minus 2 is 0. And then, after it does this computation, it's going to store it in the current row. Okay, so I guess the one thing I have to make sure is that we skip the pivot row, because we don't want to do this to the pivot row. So we have to put an if statement here. If index is equal, we have to use two equal signs when we're checking equality. Otherwise, it'll say store the second, store the right-hand side inside of the left-hand side's position. So if the index is equal to pivot 1, so that's the pivot row. If index is equal to pivot row, then do nothing. Otherwise, do this. And so we will close our if statement here. And then, okay, so now this for loop looks done, I think. So first we set our index to 1. We check, is the index less than the number of rows? If yes, we check, is the index equal to the pivot? If yes, do nothing. If no, then set the current row of the matrix, the the current row of the matrix is the index row of the matrix. Silly. I'm creating too many variables that not all of them are needed. There we go. So take, so the index counts which row we're on. So yes, if the index is different from the pivot, that's what the second, the way an if statement works is if the first statement before the comma is true, do the thing between the next two commas. And if not, do the thing after the next two commas. So if the index is not the pivot, then take the index row of the matrix and set it equal to the index row minus the entry that's in the index row in the pivot column times the pivot row. That will give us our 0 in the index row pivot column that we want. And we want to do this for all of our rows in our matrix. Once our index is greater than the number of rows, we will stop and drop out of the for loop. Okay, so this here seems to pivot for us. And we don't need this variable, we didn't use it. I guess we didn't use our pivot entry, we just, where is, we, this would be our pivot entry, we didn't call that variable either. But that's okay. And we didn't need to set current row equal to anything. We have our index, our number of rows, and wonderful. This should work now. So we will execute this code. That'll store this as a function in the program. And then we will try this on our matrix. We'll try this on our matrix. So okay, so what I have here, and we'll clear out all of this junk. What I have here is I've given it a matrix. It's this 2x2 matrix, and I'm gonna change this to a 4. If we've done our programming right, this says that the second row third, oh, we don't have a third element. Second row, second element is the pivot. And to do the operations on this matrix, where this is the first row, and this is the second row, and so on. So now, and, oh, we don't want to do matrix form that. We want to do pivot this. There we go. So what's going to happen is we've handed pivot, which is the function we just wrote, the matrix and the coordinates of a pivot. And it should pivot around this. Then we're giving this pivot will give its matrix output to matrix form, and the matrix form will take this kind of hard to read list notation and turn it into a nicer looking normal matrix. Oh, we did forget to do something. So we need to put a semicolon here. This semicolon says that this line of code terminates here at this semicolon, and if we didn't have it, then it would try and multiply this statement, which is store a matrix in a certain spot, with this for loop, which would be really weird. It wouldn't know what to do with it. That's why we have a semicolon after the if statement and a semicolon after the for, because otherwise Mathematical will try and multiply things, and then it'll get confused because it doesn't know how to multiply a for loop and a matrix. Okay, so the other thing that we need to do is, so we need to do need a variable here. We need to have our manipulated matrix. Or I guess we could just call it a matrix, and that would save us some typing. And we will name this the input matrix. Okay, so what's going to happen is it's going to take in this matrix and it's going to store it in its private spot, and then do all of these manipulations to the matrix. So matrix is now a local variable because it's declared inside of the curly braces of a module. So it won't be modified from the outside, it'll be modified internally. And then once we're done with all of our for loops and everything, we put matrix here. So we'll take an input matrix, we'll store it somewhere safe, we'll do all of our manipulations that we need to it, and at the very end, we will take the final matrix, which has been manipulated to be what we hope is the answer, and we will return it. So, okay, now that we have our return statement here, that we'll give back our matrix that we took in, then now we should have it right. The pivot will take in a matrix, it'll take in a pivot coordinate, it'll pivot around that, it'll spit out a matrix, and matrix form will turn it into a nice pretty matrix. So now when I try executing this code, it says that there's an error, which is normal for programming. Usually the first time you try and run something, it doesn't work. At least for me. Set. Ah. Let's see if that fixes it. That should fix something at least. Okay, so let's see what we have here. So, what it did was it divided the pivot row by the pivot entry, which is what we told it to do. Then it multiplied the pivot entry, which is 1, by the number above the pivot, which was 2. It multiplied the pivot row by 2, and then subtracted what it got from the upper row. So that looks right. 1 minus 3 halves, because 2 times 3/4 is 3 halves, and we're subtracting. So 1 minus 3 halves is negative a half, and then 2 minus 2 is 0. So this did look like it pivoted correctly. Let's add another row, and let's add another entry to each row, just to make sure that this can still work. We have 5, 6, 7, and let's add 8 and 9 here. Okay, so when we execute this now, we get this matrix, and let's blow it up and see if it worked properly. We definitely have zeros above the pivot, which is the goal when we're pivoting. This should still be a negative half, just like it was down here, because we didn't change that entry. We have this 5 that turned into a half, so I guess we got, yes, so we had 1 times 6 is going to be 6, and then we had 3/4 times 6, which is going to be 9/4, sorry, 9 halves, and then we have 5 minus 9 halves, which is going to be the same as 10 halves minus 9 halves, which leaves a 1/2. Great. Let's see what happened there. So we had 2 times, let's see, we had this 4 was divided, okay, so this 8 became a 2 because we divided everything by the pivot, so this is a 2 here, and then we had 1 times 2 is 2, so this 2 became a 4, and we had 9 minus 4 became 5. Yes, it looks like our pivot command works. So we give a matrix and a coordinate to pivot, and it will pivot for us. So now what do we want to do? Well, pivoting is definitely part of our program, but it's not all of it. So we need to write the rest of our program now. So what we want is, if we identify, let's identify the pivot column. So okay, so the pivot column, we will hand an input matrix to our function, and we will also do another module. Oops. And the pivot column will spit out a regular number. Let's see, we want to have an index, and we'll set the index equal to 1, and we need a matrix to manipulate, which will be where we store our input matrix. And if we need any more, we'll come to those. So 4, we get our index equals 1. Usually I just write I for my index. A lowercase I is fine. But I'm writing out words for my variables because that's good programming when what you're programming is going to be used by someone else. So for index equals 1, index less than or equal to So we'll want our number of columns, which is going to be equal to the length of the transpose of our input matrix. There we go. We're also going to need to close our for loop with a close brace and a semicolon. Okay, so index less than or equal to the number of columns. Index plus. So index plus plus is shorthand for saying take index, add 1 to it, and store it where index was stored. Okay, so now that I have this, what I want to do is I want to look at the matrix, add the, I want to look at the bottom row, so I'm going to need to have the number of rows too. There we go. Okay, so the matrix at number of rows, comma, index. This will pick out the bottom row and then pick out the index column in that row. So now I want to look at this, and I want to figure out which of these is the most negative. Okay, so I guess I'll need another variable that'll be most negative so far. I will set it equal to 1 because you know, when we look at just one column, then that'll be our most negative. It's only after we look at more than one column that we might have a column that's more negative than the first. So we'll check. No, we'll set it equal to 0. We need the index of the most negative, and we need the most negative value. So let's actually rearrange those as value will be the value of the most negative number, and we're going to set it equal to 0 so far. And then we're also going to get index of most negative. That's going to equal 1. There we go. So for our loop, we want to check to see if the indicator in the bottom row and in the index column is less than or equal to the current most negative number that we have. So if this is going to be less than value, then we want to store this number to our value. And we want to change our index to so the most negative index. That's not what I called it. What did I call it? Index of most negative. There we go. It's going to be equal to the current index. And otherwise do nothing. So we're done. Okay, so the way that this if statement works is it checks to see is the indicator that we're looking at less than the value that's currently stored in value? If it is, then store the indicator we're looking at in value and take the index of that value, the index of the indicator we're looking at, and store it in index of most negative. Okay? By the time we get to the end of our row, actually, we don't want to look at the last element of the row, so we're going to change this to a strict inequality, because the last element in the indicator row is not an indicator. Only the values in front of that are indicators. So we have this here. Index of most negative equals index. That's great. And we want to check, well, I guess we'll write another function to check that. So we'll have it return the index of most negative. Great. So now when we run this on a matrix, it should scan the bottom row, except the last element in the bottom row, and return the column of the entry that is most negative. And it'll return a 0 if there's nothing that's negative. So let's execute this code, and then let's see if it works. So we'll do pivot column of, we need a matrix. Let's grab the one that we had earlier. Oh, we don't have it anymore. Okay. We're going to have 3 rows and 3 entries in each row. And we'll go 1, 2, 3, 4, 5, 6, -1, 2, -3. So it should pick out the -1 because it shouldn't look at the -3 at all. So, so what it should do is it should start by looking at this -1 and then say, oh, this 2 is positive, therefore it's not less than -1, and I don't look at the last column, and return that 1 is the most negative element there. So let's run it. We got a 1, and that's correct because this 1 is in the first column, or this -1 is in the first column, so this is the number of the column it's in. Now if I switch this to a -2, now it should pick this -2 because the -2 is more negative than the -1. So when I execute this code now, it should run a 2. Great, it did. Let's make some longer let's do we added 3 entries here. There we go. Now it should pick out this -3 because these things are positive and these things are less negative than the -3. The 8 doesn't matter because it's the last thing in the row. And great, it picked out the 3. Wonderful. And then it should spit back a 0 if all of the entries are positive. No, it gave us a 1. Okay, I understand why that happened. So, we want to say if value is less than 0, then we want to return this index of most negative. Otherwise, we want to return 0. Okay, so putting this if statement in, and we have to close off our if statement and put a semicolon. This if statement will check the current most negative value. Remember how we set the let's see, we set our most negative value equal to 0 at the beginning, okay? So if all of our entries are positive or 0, then that value will never change. It'll remain 0 the whole time. And so if value is not less than 0, then instead of returning the index of the most negative column we've encountered, well, none of the columns will have been negative, so this index will remain a 1 the whole time. Because this statement failed, because value was not negative, we don't return this, we return a 0 instead. So now when I execute this code, because all of the entries except the last one, which doesn't count, are positive, then instead of returning a column number, I return a 0. That didn't work. Okay, so what happened? If value is less than 0, index of most negative value. Why did it return a 1? Oh, let's try that. There we go. Here's the 0 that we wanted. So the reason I want it to return a 0 is this gives us a way of checking to see if we're done with our pivoting, because returning a 0 will mean that all of the indicators are positive, which means that we're done with our tableau, or we're done with our simplex pivoting and stuff like that. So now we have two parts of our program done. We have a pivot method, and we have a method of finding our pivot column. Now we need to figure out how to find our pivot row. So we want a method pivot row, and it'll take in a matrix, and it will take in the pivot column. And with it, we will have a module. We're going to need an index, which will set equal to 1. We're going to need to know the number of rows, so which will set equal to the length of our matrix, our input matrix. And what else do we need? Oh, we'll need to have a place to store our ratios. So let's see. We'll have the pivot. No, we don't know the pivot yet. We'll have the ratio, which that's where we'll store ratios as we're looking at them. The current ratio and the current ratio row, and we need to know the number of, do we need the number of, no, we don't need the number of columns. Yes, we do need the number of columns, because we need to figure out where our constant column is. That'll equal the length of the transpose of our input matrix. Okay, I think that might be all that we need for now. So, put our comma, not a semicolon, a comma, and we close that off. So, what we need to do is we need to do a for loop. For index equals 1, index has to be less than or equal to, no, just less than the number of rows, because we don't care about the pivot column. Sorry, the indicator row. We don't care about the indicator row. So as long as the index is less than the number of rows, we'll keep going, because when it's equal to the number of rows, that's the indicator row, and we don't care. And then we'll do index plus plus. Okay. Let's see. We want to get the smallest ratio that's still positive. So, we actually have to start at an index of 2. And this is why. We're gonna set our current ratio. We have to make sure our current ratio isn't negative. Oh, no, we'll start it at 1. So, if what we want to look at is if the matrix, we want to look at the current row, so that'll be the index, comma, we want to look at the pivot column, and that number was given to us, pivot column. So if matrix index pivot column, we want to take the constant value divided by this, so take number of columns. Okay, so what we're going to do is we're going to take the row that this is the row that we're currently on. We're going to grab the last element of the row. So this is the last element of this row, and we're going to divide it by the element in this row that is in the pivot column, and that'll give us a ratio. And we want to know if that ratio is greater than 0. So if this ratio is greater than 0 and let's see. Ratio equals null, then current ratio equals this ratio. There we go. Okay, so what this checks is to say, do this ratio. Is it positive? If it's positive, check, is there something stored in current ratio? So if it is positive and there is nothing in current ratio, then stick this in current ratio. Okay? Let's see. Okay, and otherwise it'll do nothing, because if it fails, either we had a negative. Nah, I don't want to do that. I want to just check if the ratio is negative. This just checks if the ratio is positive. If it's positive, then it does this thing here. It stores the ratio in current ratio. I don't want it to do that quite yet, though. I'm going to put another if statement in here. So we have if current ratio is null, then store this ratio in current ratio. Otherwise, what I want to do is check if current ratio is less than this number, then do nothing. And if it's current ratio is greater than, then I want it to switch. There we go. Okay. Otherwise, do nothing. Okay. So okay, so what this string of nested if statements says is that first, if the constant column entry divided by the pivot column entry in the row is, if we divide the one by the other and we get a positive number, move on. If not, then stop. Then the next thing it checks is if the current ratio is null, store that what you've just divided in current ratio. Otherwise, check to see if the thing that's already in current ratio is bigger. If it's bigger, then replace what you were holding as the current ratio with what you just divided. Otherwise, do nothing. And then it exits all of the if statements. We have to see where our for loop ended. Down there. So we need another. So this is the end for our module, this is the end for our for loop, this is the end for our outermost if, our middle if, and our innermost if. And at the end of all of these if statements and for loops, what we'll end up with is either we'll get the smallest ratio, which will be stored in current ratio, or we will end up with null, meaning that all of our ratios are either negative and or zero, and that will spit out a null entry. So let's see. What we also need to do is every time that we're replacing, so current ratio equals null, current ratio equals this. What we need to do is we need to make sure that our current row entry, not current row entry, we want current row current row number is equal to our ratio. Sorry, equal to our index. Let me go rename this current row, or current ratio row number. What did I call it? Current row number. Okay. So the current row number stores the row number of the smallest ratio so far. And so once we have determined, for example here, that the current ratio should be stored, that the ratio should be stored as current ratio because it's the best candidate we have so far, then this will remember where that was. And here we've done it again. This is going to also need current row, not row entry, current, called it row number equals index. Okay, so, and then we will return current row number. This will tell us the row of our pivot entry. So we will hit enter, and we've executed this code. Where's we forgot to say matrix equals input matrix. There we go. And now everything's turned green, so we are good. Now we need to test this out. So let's say that we have a matrix. Let's pick a nice small matrix for now. So let's say that the second column is the pivot column and fill this with we're going to need to have 3 entries. Okay, so we have, let's see if this will give us something sensible. So it says that this is the second column is the pivot column. That's the column that contains 2 and 5. We're going to need 3 rows. Okay. Okay, so what it's going to do is it's going to look at the last entry in a row, divide it by the entry in the second column, yeah, the pivot column. So it should look at 3 halves and 6 thirds, so this is 2. And then it should say that 3 halves is less than 2, so that means that the first row is the pivot row. Let's hit enter. So something happened. Let's take a look at this again. Start off with index being 1. Index is less than the number of rows. Increment index each loop. If so, this is picking out the index row and the last column, dividing it by the index row pivot column, which is what we want. It's checking to see if that's bigger than 0. If it's bigger than 0, then the next thing we do is this if statement, which, where does it close? Closes at the bottom, of course. Okay, so if the current ratio is null, then store store this quotient that you found to current ratio, and then store index to current row number. Okay, so far so good. And if not, so this means current ratio is not null, then check to see if the current ratio is bigger than what you just, the ratio you just found, then set the current ratio equal to what you just found, and set the current row number of the least ratio equal to the index. And then we close out of our if statement. Close out of this if statement. We close out of this if statement. Close out of the for loop. It's nice that it lights up green to show you where these things happen. And then returns current row number, and then ends the module. Okay, so this should work. Current row number. So if look at this, have pivot column row. Take in our input matrix and our column number. Okay, so I've renamed my variables. That might make it clearer for me to see what's going on. So now I have current ratio is, when I look at the entry in the row and the entry at the end of the row and divide them, that's my current ratio. So I enter my for loop. First thing I do is I calculate my current ratio, which is the last entry in this row of the matrix divided by the pivot column entry in this row of the matrix. Now, good debugging practices include writing print line statements at places where you can check to see what's going right or wrong. So what I'm going to do is I'm going to put a print line statement here. And in Mathematica, it's just called print. I'm going to have it print matrix, or no, I don't need a matrix form, it's not a matrix, but I'm going to print the current ratio. And I will have it print the current best at the end of each loop. So that'll be here. Now, when I execute my code, it doesn't know what current best is. Okay. So, but it does know what the current ratio is. And it doesn't know what current best row number is. I'm going to set this equal to 0. I'm going to move my, I'm going to delete this current ratio. But I'm going to have my current best be printed, cut. So it should be null at first. I also want to put a print line saying so we want to print a string literal here, so I'm going to put quotes around it. That's going to print check best greater than current. And I'm going to put a print line here. Which is going to say print checked best equals null. So now when I execute this code, separate this. Oh, it never got to these parts of the if statements. Current ratio is greater than 0, print. Oh, because the current ratio, wait, it's saying the current ratio is never bigger than 0. try this. Current ratio. Let's see. If the current ratio is equal to matrix index. Six-fifths. If current ratio is greater than 0, then we execute the code right after that, which is print current ratio. If current best equals null, is current best not equal to null? Okay. So the first thing that we're going to do before our for loop is print current best. See if it is indeed null. Current best does appear to be null. Current ratio is 0. And current ratio. Checked current ratio greater than 0. Okay, well, instead of setting current best equal to null, let's set it equal to infinity. Okay, so any positive number you get should be less than infinity, so now we don't need to check if it's null. We actually don't need this this bunch of code at all. Okay, so now the first thing we do is we set current best equal to infinity. We enter our for loop, we check to see if the index is less than the number of rows. We set our current ratio equal to the proposed pivot ratio. We check, is this ratio bigger than 0? If it is, then we do our print lines. We go to our next if statement, say, is the current best bigger than the current ratio? Well, anything that isn't infinity is going to be smaller than the original current best, and it'll replace it. So we will replace our current best with our current ratio, and we will go back through our loop again. So okay, so it's claiming that our second row has the best ratio. So 3 over 2 is 3 halves. and 6 over 3 is 2, which is bigger. So this is incorrect. I think. Pivot column. Current ratio greater than 0. Let's get rid of our print lines. Okay, so first we check, is our current ratio bigger than 0? If yes, we check. If current best is greater than current ratio, then we replace our best with our current ratio, and we replace our current best index with our new index. Why is it picking this row instead of this row? Okay, so this print statement will print the current best, then the current ratio, then the index of the current best, and the index of the current ratio. So, saying that when we first enter this, our initial best value is infinity, which is what we set it as, and our current ratio is 3, and the index of our current row is 1, and it says that then as that loop goes, we replace our best ratio, which was infinity, with 3. This is big enough to see now. So this is the current ratio. It compares it to the previous best and replaces it. Compares this ratio. Why is it 6/5? 6/5? Strange. Because it should do index or number of rows, index pivot column. So our index should be which row we're looking at, our number of columns. So it should be looking at the first row. Okay, so 3 over 1 and 6 over 5. Okay, so it is doing what we asked it to. I just thought I'd given it a 2 to look at instead of a 1. Anyway, so we have 3 over 1 and 6 over 5, and 6 over 5 is definitely smaller than 3, so it spits out it ends up spitting out 2 as the answer, which is correct. And if we change this to a 2 and run it again, then it'll compare 2/3 to 6/3. Sorry, it'll compare 3/2 to 6/3, so it'll compare 3/2 to 2, and it should pick the second column then. Sorry, it should pick out the first row, which is this here. Okay. I was confused, but it was answering the question I asked it, not the question I thought I'd asked it. Okay. Okay, so let's take out this print line statement. Where did I put it? Ah. Okay. And one last time, let's add another column to this and see how it handles with negative entries sometimes. Okay, so now when I tell it pivot row 2, it should look at the second entry. I'll say 3 over negative 2 is negative, ignore it. And I'll say 6 over 2 is 3, which is less than infinity, so that's good. And it should return row 2. Let's check that. And it indeed does return row 2. And now if I change this to a positive 2, now it goes 3 over 2 is 3/2, and 6 over 2 is 3, so it should return row 1. And indeed it did. And oh, if I make them all negative, or if I make both of them negative, it should return row 0, which indeed it does. Which there isn't a row 0 on the matrix, but this gives us a way to tell us when we've failed. Okay, so now we can find the pivot row and the pivot column, and once we've found them, we can actually pivot. So now we are going to write a module that actually does our whole simplex method. Okay, so that's going to take in a matrix. And that's all we need, actually. We just need it to take in a matrix. And then it'll have a module. Okay. And inside our module, let's see. Oh, we need to write a method. We need to write one more method. We need to write a method that will determine if the indicators are negative. So say are indicators negative. And it'll take in a matrix. Cool. Need an index and a number of rows and a number of columns. So the number of rows is just equal to the length of our input matrix. and the number of columns is equal to the length of the transpose. And do we need anything else? I think not. So, we do a for loop. If we were fancy, we would do a while loop, but for loop is fine. So for index equals 1, index less than number of columns, index plus plus, comma, if let's see, we need one more variable, and it'll be our index number. Okay, there it is. We'll say, what do we want to call it? We want to have it be a Boolean. What do we want to call it? We'll say, call it yes equals false. Okay, so what this means is that our indicator's negative. We're going to have it return yes at the end of our for loop. Okay. And yes will be false if we didn't find a negative indicator, and yes will be true if we did. So basically, if this were like a question, like, are the indicators negative? Yes is a true statement if there is a negative, and yes is a false statement if there are no negatives. So we're going to say if we also need to store a matrix. Put it somewhere. Matrix equals input matrix. Okay, so if matrix number of rows, because we want the bottom row, comma index is less than 0. Okay, so if this matrix is less than 0, that means that we found a negative thing. And that means we can set yes equal to true. And if we don't find a negative, then we leave yes alone and we go to the next one. And at the end of the whole thing, we return yes. So what is wrong? There's our if statement. There's our for loop. It's our module. There's something wrong. Oh, I need a comma here. There we go. You need a comma between your module's internal variable list and the rest of the module. Okay, so this should work now. So now if we feed this a matrix, well, let's take this, we're going to cut it out, I'm going to combine this cell with this previous cell. There we go. So what happened here is we returned 0. Why did we return? Oh, we returned 0 because we typed it wrong. Our indicator's negative. It didn't know what to do. We gave it too many arguments because our indicator's negative takes in a matrix by itself, and we had a matrix comma a number. So we fed it this matrix. Now, the indicators of this matrix are everything in the bottom row except the last entry. And this function checks to see, are these is any one of them negative? And if they're all positive, we return false, like we just did. And if one of them is negative, then it'll return true. There is a negative one there. So this method will tell us how to we'll have our matrix equals our input matrix, and we'll do a while loop. Now, while loops are different from for loops. For loops execute until the index of the for loop hits the top number, and then it stops. While loops are different. While loops will check something, and it will continue to re-execute the code over and over again until whatever you've told it to check comes back false. So, while our indicator is negative, matrix, comma, our thing. So this this method here, the simplex method, will take in an input matrix, and it will check to see, are the indicators negative? If they are, then it's going to do we need to have our pivot row or pivot column, and so we'll let our pivot column gets decided first equals pivot column, comma, matrix, and then pivot row equals matrix, comma, pivot column, and then we're going to have our matrix. We're going to pivot. Okay, so first we're going to figure out what our pivot column is by calling our pivot column method and giving the matrix to it. Then we're going to find our pivot row by taking our pivot row method that we defined earlier, feeding it the matrix and the pivot column number, because that's how we defined that function. So notice how pivot column just takes in a matrix, but pivot row takes in a matrix and a column. So we need to give it both. And then matrix takes in, pivot takes in the matrix and a list that the first entry is the pivot row, the second entry is the pivot column, and that's how we defined it here. So the input matrix and our pivot, where pivot 1 is the row, pivot 2 is the column. And once we've pivoted on this matrix, we will return this function to matrix, and then we'll go back to what we need to check. So the while loop will check, are the indicators negative? If true, it'll do it again. That means if it finds one negative indicator, it'll do it again. And if it doesn't, then it ends, and we will return matrix, which will be completely done with this simplex method, and that'll be our answer. So let's find, what are we calling this method? Simplex method. Oops. Let's combine this with this. We'll say simplex method. Ooh. Okay, so it says that we hit recursion limit, so we'll have to quit our evaluation. Okay, so what went wrong? So we gave it a matrix. First thing it did is it figured out pivot column of the matrix. I'm gonna shrink all this down. You saw me write it, so I just need it smaller so that it's not quite as hard to read. Okay, so let's execute these. Simplex method takes in a matrix, stores it to matrix, pivot column. Okay, so maybe it I'm going to rename these. Instead of pivot column, it's going to be get pivot column and get pivot row are our methods. And then I think what's happening is it was getting confused because I was calling my variable pivot column and I was calling my function pivot column, and it was getting those mixed up. So let's clear the kernel again, make sure that all of the garbage is gone. We'll execute this code here, and then we'll try it again. I'll try it again. There we go. Yeah, that's exactly what happened, is that it got confused. It didn't know the difference between pivot row, the function, and pivot row, the variable. So it claims that this is the matrix. Oh, while we're at it, we'll do a matrix form around matrix. Now when I do this, it'll spit it out in the form of a matrix. So this, it claims, is our reduced form. So this simplex method on this matrix here produces, this is our matrix. Now, this was just random numbers that I typed in, but let's try this on a problem that we've already solved. So, there's yesterday's carpenter problem where we use 75 feet of our 100 feet of wood to make 75 toy boats. Let's set up this matrix in that for that problem. So we had a 3, we had a 1 and a 1, and we had 4 ones, and then 2 zeros, and a 100. So this represented that, let's see. Oh, this isn't the wood boat problem, I don't think. Anyway, it is a problem that we solved yesterday, though. So we have x1, x2, x3, slack 1, slack 2, z, and 100 as our first row. And I'm going to just delete our next 2 rows, copy and paste this one, because it has the right number of entries. 2, 3, delete that. Okay, our next row was 5, -1, 2, 0, 1, 0. There's a 1 here, and 150. And in the last row, we have a -1, a 1, a -2, 0, 0, 1, and 0. So this here is our completed simplex method. So this tells us that we have a 0 for x1, which is what I have as my solution here. We have a 0 for x2. We have a 75 for x3. We have a 25 for s1. We have a 0 for s2, and we have a 150 for x3. Wonderful. That is exactly what I have listed as the solution to the problem. So we have reason to believe that we coded this correctly. So now we have a Mathematica notebook that can be used to do simplex method on our matrices. So let's check all of this code here. Take this, and we will make it all the same size. Oh, what happened? Did I accidentally delete something? That's our while loop. Huh. It's weird. Oh, there's space there? Okay. Maybe this is bolded or something? Doesn't matter. It seems to be working, even if it's a weird font. Okay. So we'll delete this. We'll delete this. We'll move this cell up to the top. And we'll shrink this down to a reasonable size. So, if you were to use this Mathematica notebook, let's save this as, let's call it the simplex method. Okay, so if you were to open this, the first thing you'd have to do is you'd have to put your cursor somewhere in this big cell here, somewhere inside of it, and hit Shift Enter. Once you've done that, it'll store all of the code and make it usable. Then you type your matrix in here, where each of these little tiny lists that are, started and ended with curly braces represents a row. So this is the top row, and this is the middle row, and this is the bottom row of my matrix. And the entries from right to left, or left to right, are exactly as top row has a 1, and then a 1, and then a 1, and then a 1, and then a 0, and so on. Okay? Actually, to make it even easier, we will have matrix equals. We will have the matrix here. We will have great. So you'll type your matrix up here where it says matrix. And what it'll do is it'll show you the matrix in matrix form so you can double check to make sure all the rows and columns are right. And it'll show you the simplex method solution. So when I do this, this top matrix is the matrix you put in, just in an easier to read form than the way that you put it in. And then this matrix here is the answer. So first you have to execute the bottom code, then you adjust your matrix and you execute the top code, and you'll get your simplex method answers here. And that's it. That's all we're going to do for our live stream today. Hope that you're having a great Friday and that you enjoyed watching me write some code. I'm not a CS major by trade, so I'm sure that there are several things that could have been improved. If you were more skilled than me, you could have done it better, but this is what I did, and I'm going to email it to my students now, so I hope they appreciate it. So, anyway, I hope that you are having a great time learning calculus, and have a great day. Bye.